So one of the nice things about teaching environmental science in Santa Barbara is we get to talk a lot about Santa Barbara. We're like the epicenter of your textbook. Everything that happens in your textbook is basically a deal in Santa Barbara. And one thing that's a really big deal in Santa Barbara is El Nino. All over, like, there's kids in Kansas who have to learn this and they got no connection, but you probably got a connection to El Nino. Because if you've been to Santa Barbara long enough, you've seen one of our El Nino seasons. We can get really, really hot water in the summer. We can get really, really wet rains in the winter. We can have huge mudslides up in the mountains during El Nino years. We can have unusual amounts of rainfall that you'll remember forever, like flooding in Isla Vista and stuff like that. I've been here for a while now, so I have experienced some El Nino. And you have to know this anyway for the AP test, so here we go. I'll explain a thing about the planet that affects you. You'll need a lot of notes for this one. You may want 2 columns like El Nino and La Nina. Some basics are on the screen now. El Nino is also known as ENSO, the El Nino Southerly Oscillation. That's on the screen. And it's a cycle. This thing goes back and forth. So there's one set of conditions, and sometimes it changes, and then it goes back. It's a cycle, okay? The timing is irregular and kind of mysterious. Like, you can kind of see it starting, but it's tough to predict. So on average, we've had El Nino cycles every 4 or 5 years, but we've had it go for like 8 or 12 years without a real El Nino. And you can get like a strong El Nino a weak El Nino that backs off. Those are called Modoki years, where it's kind of in between. It's neither. Some are more extreme than others. It's pretty mysterious. We know what it is, but we don't really understand why it gets kicked off. Like, what changes about our atmosphere that changes the ocean that fires off an El Nino. You should know that most of the time we have La Nina conditions. So the little boy and the little girl, El Nino, La Nina. What do we call this? The outdated gender modality. La Nina conditions are the more common one. Most years are either La Nina or a little bit less extreme. So some books will discuss normal and La Nina is just slightly stronger than normal, but El Nino is rare. That's weird. That's very different. And it's a tough explanation. I took a whole class on this. I swear, an entire quarter on this. And I can only give you like a 10-minute lecture because that's all I understood. So remember those big ocean currents? We put this in earlier in this course. It's on the screen again. And I want you to focus where that circle is. That's called the trade winds. Stuff that goes from the Americas across the equator to Asia. Okay, you have to know that. So look at that image. There's all this stuff cruising across the Pacific at the equator. So you've got Central America on the right of that circle, and you've got Indonesia on the left of that circle. Okay, that's the Pacific Ocean at the equator. America's Indo. And what's normal is what you see there, that you have strong wind, trade wind. So you get strong ocean movement, you blow across water and the water moves. So the trade wind makes a trade current. And I don't know that I put the word trade in my slideshow because I'm an idiot. So you definitely want to make sure you write that down. That's trade wind and trade current. That has been on the AP test, sorry. And so normally, oh, there it is, yeah. Normally what this does, the strong trade wind in the Pacific makes these strong currents that push all the surface water toward the west. And think about it, you're in the equator, so that surface water gets hot, right? because you're in the equator and it's hot on the surface. So the water gets like 80, 82, 85, 87 degrees. And all that water gets pushed by these currents over toward Indonesia. Think about what that's going to do in Indonesia. You would have really warm weather and you'd have a lot of rainfall. And this checks out. This is actually the wettest forest on the planet. In Indonesia, they get more rainfall even than the Amazon or the Congo. If you're a surfer, you know that a surf trip to Indonesia, you don't take neoprene because you can surf all day, any part of the year, and all you need is a t-shirt to keep the sun off, right? Hot, hot, hot surface water, steamy clouds with lots of rain in Indonesia. That's normal. If you go to the other side, that means that you've got offshore winds pushing the water away from the coast in Central America. And hopefully I put this in your warm-ups, but when you push surface water away from the coastline, that's going to draw cold water up from the bottom. That's called upwelling. And so this also checks out. If you've ever noticed that part of the equator, Peru, Ecuador, that part of the equator is extremely cold and dry. Some of the driest deserts, the Atacama Desert, for example, are on the coast of South America. And you know, if you're a diver and you've ever gone to the Galapagos Islands, it's beautiful diving, huge hammerheads, the big turtles and the marine iguanas and stuff. Go to the Galapagos, you'll love it. But take a 7 mil wetsuit because the water's frigid. It's like diving in Alaska. But you're at the equator. That's what Ecuador means. But the water's frigid. Trip out on that. So what's normal is that our side of the Pacific, the Americas side, has cold, dry weather, and the other side is hot and steamy because all the hot water is getting pushed over there. If you had a big bowl of steamy soup in front of you and you push it toward the person in front of you, well, there you go. These big currents are pretty reliable. By the way, that also brings cold water down from Alaska to us. So we have like a really strong Humboldt current, also called the California current, and that comes out of Alaska. So we get cold water, so we get good fishing. Okay. But for some reason, you see those white arrows right there? Imagine that they were going to disappear. For some reason, the trade wind stops. And technically, like if you really want to nerd out, it doesn't exactly stop. It just pulls away from the equator. So at the equator, there's no more trade wind. The circles get tighter, if that makes sense. So instead of being these big gyres that touch at the equator, the North Pacific and South Pacific circles move away from each other. That leaves like a belt across the earth where that water's not moving. That's called an El Nino, where all that hot surface water does not move. That means that the hot surface water is no longer going to Indonesia. Compared to the usual, Indonesia gets colder and drier. All that water vapor makes rain in the middle of the ocean. It doesn't all travel to one place. All of Indonesia's rainfall gets spread out across the equator, which means on our side, we're closer to warm water and we're closer to rainfall. And that kind of affects the entire edge of the Americas because those circular currents got smaller. So there's water just sitting there warming up on the coast of the Americas. So if you know El Nino in Santa Barbara, we get bigger rains because the ocean is warmer and steamier. And we get crazy fishing, like yellowtail will come into the 1 Mile Reef right in front of the harbor, which is not normally found there because that water is normally pretty cold. The crazy thing is this affects the whole planet. but we experience it the most. If you were to map La Nina and El Nino, you know, the same thing also happens in the Indian Ocean and to a lesser degree in the Atlantic Ocean. But the really big change is ours. So these South Americans named this system, and they really notice it in December. So El Nino is the baby Jesus. It happens around the new year when South Americans celebrate Christmas and the Four Kings on January 6th or something. Anyway, the big impact is here. Of course, you'll notice for Santa Barbara, we're usually pretty cold and blue, but we also get some leftovers of that impact. Okay. You can see that the biggest change is at the equator, and that really affects the Americas. This affects cloud formation and rainfall, and don't forget the upwelling. See, when you push away all the water, that's going to pull up the cold water. If you're not pushing it away, there's really nothing to draw cold water upward. So El Nino started as a thing that the fishermen noticed. El Nino has so much to talk about. So I just want you to know what I have seen on the AP test, okay? It's a cycle that's usually the La Nina, but rarely the El Nino conditions. This is all surface winds that drive ocean currents, the trade wind, trade current. This affects both sides of the Pacific. And if you measure all this energy, these are massive movements of heat. Like, that's a lot of water, and surface water gets really hot. So when you bring up all this cold water to the surface, that's a huge air conditioner. And when you dump all that heat in one place, that really turns on the heater in one part of the planet. So this has impacts that are really important when we talk about climate change, but that's so confusing because you can't really predict El Nino very well, right? If El Nino were predictable, this would totally change climate models. But we factor this in with a lot of margins of error. This is one of the reasons that we're not more certain about weather predictions and about climate forecasting, because there's these big, mysterious variable shifts. I think that covers everything you needed to know for the AP test. Bye.